Hello students. So let us see this question on electrostatics. Okay. So what is the question saying? Each of the figures shows electric field vectors at 2 points A and B in an electric field. Okay, so here you can see in this diagram it is showing electric field vectors, okay, at 2 points. In which figure can the illustrated field be created by a single point charge? Now the question is that in which of the case this electric field lines have been created by a single point charge. So let us go to each of the option and check, right? So if you are seeing the first one here, at this point you can see and this point you can see, right? Field lines, two field lines are there. Let us try to extrapolate and see where the charges are meeting, right? So if you will see here, it looks like that there is a point where these two field lines are meeting. That means the field lines must be emerging from that point, and because these field lines are emerging, there must be a positive charge, obviously, right? Now if you see here, the length of this line is giving the vector, right? It is vector representation, not just the field. It is vector representation. So the length of this line gives the magnitude. So here magnitude is showing larger and here magnitude is showing smaller. Now you can think about it. Is it correct? Is it correct or not? Because as we have drawn this, you can see that this length, this line, this length is smaller and this is like hypotenuse, right? So if you consider the distance, large distance or larger distance from the source or from the charge, that means field will become smaller. So at this point the field is smaller because the distance hypotenuse is larger. Here this distance is smaller. Let us write this point as O. So this distance OB is smaller, so field is larger. O is representing a charge, right? So definitely this option can be correct. This option is correct. Let's check here. Now here same approach when you extend this one, right? This is the point O, this is the charge, right? Now here this distance OB is smaller, so field should be larger, but here field is showing smaller, so this cannot be correct. Okay. Similarly, now see here. Now here there can be confusion that how the field lines are cutting. This is not the field line, it is the vector. Okay, it is the vector. So here vectors can be translated, so it is representing the field vector here and field vector here. Same thing, apply the idea. Now here when you are seeing this point, these two lines are intersecting here, so there must be a charge here, and the field lines are going towards this point. That means here there can be a negative charge, right? Negative charge. But anyway, now again you have to see the distance or the magnitude of the field. So here this distance is smaller, so this field must be larger, and because this hypotenuse is larger, so field must be smaller, which is correct, right? Because this length is small, this length is large, so definitely this is also correct. Now if you see here, because again same thing, if you see here this point, you have to take negative charge and this distance is small, so field must be large, but this field is smaller, so this cannot be correct. So I hope you got this idea, right? So what is this question? It is representing the field vector, not the field line. So you may, just by seeing, some of you may think that this is not possible because field lines never cut. It is not the field line, it is the vector representation, right?